This video, we're going to be talking about sampling and data. In this chapter, we'll be discussing some terminology, some definitions for statistics and sampling methods. I'm going to break this video into 4 sections. In part 1, we're going to focus on sampling and parameters. So let's get started. So first, let's talk about what is statistics. You're taking this course. What is it exactly? You may have some ideas, but this is what it is. Statistics is the study of procedures for collecting, describing, and drawing conclusions from information. So it's more than what you think of when you think of your typical math class. We have to collect data. And there are special ways to do that, certain considerations that we'll be talking about. We're going to describe the data, and then we're going to take what we've learned and draw conclusions from that information. So there's a lot going on here. So statistics can be broken down in descriptive statistics or inferential statistics. So let's look at the difference between the two. Descriptive statistics is organizing and summarizing your data. So think of graphs and charts, which you've most likely had experience with at some point in your life. I know that students begin making graphs as early as kindergarten. They're basic little graphs with pictures, but they are graphs that represent data just the same. So I'm positive you've had some sort of experience with organizing and summarizing data. The thing that we want to make sure of is that when we organize and summarize our data, that it gives the reader a clear and concise idea of what the data looks like. So here are some examples. Right here we have a circle graph, and here we have a bar graph. Both of these are representing data, but we're not giving the reader all of the individual pieces of data. We have consolidated them into a nice graph so that they can visually see kind of the breakdown. The other type of statistics, inferential statistics, is where we draw conclusions from the data. So we use sample data, and we'll talk about what a sample is very soon. And we use that to make generalizations about an unknown population. For instance, you might stand in a mall and ask a sample of 100 people if they like shopping at Barnes & Noble. And you could use your research and inferential statistics to reason that around 72 to 82% of the population, all shoppers in all malls, like shopping at Barnes & Noble. Now, please do not take this as fact, okay? However, that would be an example of what inferential statistics would look like, is to take data from a sample and use that to make a conclusion about the population as a whole. So let's talk about what we mean by sample, what we mean by population, and a few other new words. So the first word is population. The population is the group that we are interested in. It doesn't necessarily mean the entire population of the world or the entire population of the United States. We can be very specific about what we want our population to be. Our population could be just the population of our class that's taking statistics right now together. A population could be all of the students that attend FCC. You probably want to clarify a semester. That do you mean all students who've ever attended FCC, or do you mean current students? You could define it as only nursing majors at FCC as your population. So the population is the group you're interested in studying, and it's the entire group. Now, a sample is the group that we can feasibly study. So it would be really hard for some populations for us to collect data on the entire population, because the population is just so massive, so huge. It would be impossible to reach every individual in that population. So instead, we take a smaller group, a subset of the population, and we study that, sample that group, and then we use what we find out to make conclusions about the population as a whole. So then parameter. A parameter is a number that describes something about a population. So a lot of people think that a parameter is a statistic. Well, a parameter is like a statistic. Let's see what statistic is. A statistic, not the study of statistics that you're taking the class in, but when you're referring to a statistic that is a number, it is a number that describes something about a sample. So here's the thing. A lot of times people will use the word statistic when they're really talking about a parameter, because a parameter describes a population and a statistic describes a sample. Both are numbers. So one of the types of statistics that we use is a proportion or percentage of the population that, let's say, like the example we gave on the previous page, the percent of people who like shopping at Barnes & Noble. So the percent of all shoppers who like to go to Barnes & Noble, that would be a parameter. But the percentage of people in the sample who like going to Barnes & Noble, that would be a statistic. So again, parameter describes a population, statistic describes a sample. And what I do is I like to try to find little things to help me to remember. So parameter, population, they both start with P. Statistic, sample, they both start with S. And that's how I remember, so maybe that will help you as well. So variables. Variable is something that we record about our sample. So it's kind of like what we're collecting. Like I could ask, I could record the number of classes you're taking this semester. That would be something that we would be recording. So there are two types of variables or data. One type is qualitative data. Qualitative variables are variables that divide people or things into categories. They're non-numerical. So they're things like the color of your eyes, your favorite food, your major. List goes on and on, but the big thing here is it's not numerical. The other type of variable that we're going to have that we're going to collect data on is numerical variables called quantitative data. And these are all found by counting and measuring. And again, these are numbers. That's the big tell here, is that they are numbers. And there are two types. There is discrete variables. These are variables that you get from counting or listing. So if they ask you the number of something, like the number of pets you have, the number of siblings you have, you can count those things. I have 4 siblings, 1, 2, 3, 4. I can count that. Also things that you can list, but they're numerical, such as shoe size. So you can't really count shoe size, but you could list them because they're specific shoe sizes. There's, 6, 6.5, 7, 7.5, 8, 8.5, so on and so forth. So you could list those. Now, then there is continuous variables. Those are numerical variables as well that come from measuring. You have to measure it to find the answer there. So if they ask what's the height, height is measured, weight is measured, volume is measured, speed and time both are measured. So if you can count it, it's discrete. If you have to measure it, it's continuous. Okay, so again, qualitative is non-numbered data, categories, if you will, and quantitative is numerical data that you get by counting or measuring. Counting data is discrete, measuring data is continuous. All right, so here's an example. So I'm going to change my screen here to one that I can write on so I can do this example with you guys. Let's see if I can make it a little bigger. Okay, it says a study was conducted at a local college to analyze the average cumulative GPAs of students who graduated last year. Fill in the letter of the phrase that best describes each of the items below. And we have population, statistic, parameter, sample, variable. There are 5. But look here, there's 1, 2, 3, 4, 5, 6 possible things that we could match here. So phrases. So that means one of them is not going to work. So this might be a little bit of trial and error. Let's see. Okay, so the first one, let's just quickly go through here again. It says a study was conducted at a local college to analyze the average cumulative GPAs of, we'll do a different color, of students who graduated last year. Fill in the letter of the phrase. Okay, so we're collecting average cumulative GPAs of students who graduated last year. So let's talk about these words here again. Population, that's who we're studying, who we're interested in, the entire group of who we're studying. And a statistic describes as a number that describes a sample. A parameter is a number that describes the population. A sample is a subset of the population, a smaller group of the population. And the variable that's what we are recording about our sample. So look at each of these. All students who attended the college last year. Now, they said that the word all here. So I'm thinking if it's anything, it's going to be population. But we'll see. All right, the next one is the cumulative GPA of one student who graduated from the college last year. So cumulative GPA, but only for one student. So that's not a statistic because remember, statistic describes a population. I'm sorry, a sample. Strike what I just said. A statistic describes a sample, and a parameter describes the entire population. This is only describing one student. A sample is a subset of the population, so that's not what this is either. So that leaves variable, and so remember, variable is something that we're recording about our sample, but you're going to record it from each individual in your sample. So the cumulative GPA of one student who graduated from the college, that is our variable. So we're going to put B there. All right, so we've got this one, we've got that one. All right, a group of students who graduated from college last year, randomly selected. So I'm going to go ahead and tell you that the giveaway here, randomly selected. So when you take a sample from a population, one good way to do it, and we're going to talk about this soon, is randomly selecting the individuals to be in your sample. So this clearly is describing a sample. It's a subset that is selected from the entire population. It's the group that we're interested in studying, but only a portion of that group. Next, we have the average cumulative GPA of students who graduated from college last year. So the average cumulative GPA of students who graduated from college last year. So this one, this is the average cumulative GPA. So I would say that's a number that describes something. So like here, the cumulative GPA of one student, that was a number that described just the individual. So that was the variable. But this is a number that describes students who graduated from college last year. So what does that mean? Is that a population that it's describing or the sample? So it's students who graduated from college last year. They're not specifying that it is a sample. It looks to me like they mean all students who graduated last year. So I'm going to say that D describes a population, which means it's a parameter. So I'm going to put D here. All right, next, all students who graduated from college last year. So again, keyword is all. I'm thinking that would be a population, but we've already got something here. So let's look. All students who graduated from college last year. Population is the entire group of who we want to study. So let's go back to the top here. A study was conducted at a large college to analyze the average cumulative GPAs of students who graduated last year. So we want to study students who graduated last year. So this is the students who graduated last year. So it looks like this should be E for our population. Let's go back to A and read it. This is all students who attended college last year. So while A is a population, it is the population of students who attended college last year. It's not the population we're interested in studying. We're interested in E, the students who graduated from college last year. So we're going to erase this one and replace it with E. That leaves one left, but let's just make sure that these two match. The average cumulative GPA of students in the study who graduated from college last year. So this is the average cumulative GPA, which is a number that describes just the students in the study, and the students in the study are the students in the sample. So this is a number that describes a sample. So a number that describes a sample is a statistic. So sometimes it takes a little bit of trial and error, like with this here. They listed two different populations for A and E, and you had to figure out which one it is. It gets a little bit easier as you get more comfortable with the terminology, but at any rate, there you go. Let's look at the next thing. So now we're going to talk about sampling methods. I talked about how we would talk about how to collect data. That's what this is, sampling methods. So good sampling is one of the most important parts of a statistical study. So the key is that we want our sample to be representative of the population because we want to make inferences. So remember, we talked about descriptive statistics and inferential statistics. We want to be able to make conclusions about the population, and that's not going to happen if the sample doesn't represent the population. So to get a representative sample, you can select your sample randomly, and that's called random sampling. Random sampling is where each member of the population is equally likely to be chosen. That's what random sampling is when each member of the population is equally likely to be chosen. So a common type of random sampling that you may have heard of is called simple random sampling. Sometimes I've seen people write SRS for short. That's what that stands for, simple random sampling. And one way to do this is to put everybody's name in a hat, kind of like they did if you ever saw the Hunger Games. They put everybody's name in a hat and they drew out a name. That works if your population is small. However, a lot of populations are large, so one of the ways that you can do a simple random sampling is to number every member of the population and use a number generator to pick randomly from the entire group. And this is done quite a bit. You can actually use your calculator to randomly generate numbers. To do that, you would hit Math, scroll over to Probability. So there will be a menu at the top, PRB. So you'd click that. And then you would choose number 5, Rand Int, and then parentheses will pop up. And then you're going to enter 3 numbers separated by commas. The first number is the lowest number that you want to be in, that you want to be a possibility, and then 24 is the highest. So basically what this means is it's going to generate numbers between 1 and 24 randomly, and then this last number is the number of numbers that you want it to generate. So this is going to generate 6 numbers between 1 and 24. If you just enter the first 2 numbers, the calculator will return one number between these boundaries, 1 and 24. But if you want a specific number of numbers, you put a number in the third spot right there. Okay, so now let's talk about other types of sampling besides simple random sampling. And a type of random sampling is called stratified sampling. This is actually a group sampling. There are two types of group sampling that we're going to talk about. The first is stratified, and this is where you split the population into strata or categories and then randomly select a few members of each category. So here's kind of an illustration of that. So this box represents the entire population. And then we're going to break the population into groups. Group 1, Group 2, Group 3, Group 4. The groups usually have something in common. So think of a high school. You could break the high school up into freshmen, sophomore, junior, senior. Same thing with a college. Okay? And then, here's that SRS. You take a simple random sample from each... Oops. I lost my page there. You take a simple random sample from each of the groups, and each of those simple random samples from each of the groups form your overall sample. And the reason that you would want to do this is so that you can ensure that every group in the population is represented. So like if you had a company who wanted to do a survey from their employees, and you have two types of employees, full-time and part-time, to ensure that you have employees from both groups, you would take a simple random sample from the full-timers and a simple random sample from the part-timers so that you know that both are represented. So that is stratified. That's when you take a sample from groups. Now there's a second type of group sampling, and that's called cluster sampling, and this is where we break our population into groups called clusters. But instead of taking a sample from each group, the groups themselves are what is sampled. So it's kind of like putting groups numbering each group, right? So group 1, group 2, group 3, group 4, and then randomly generating numbers for a group of, I don't know, 3, and then those 3 numbers that represented those specific groups would be chosen for the sample, and then everyone in each of those groups would, the groups that were chosen would be in the sample. Here's an illustration that might help with that a little. Again, the whole box is the population that we have separated into groups 1, group 2, group 3, group 4, and then we randomly sample two entire groups. So everyone in group 4 was chosen, everyone in group 1 was chosen, and both of those entire groups are in the sample. So with cluster sampling, each group is not represented, but we are randomly choosing entire groups. So an example could be, we could break Maryland up, the community colleges in Maryland, and those could each be a group. So Frederick Community College, Hagerstown Community College, Carroll Community College, etc. And then we could choose, let's say, 5 community colleges out of that group, and then every teacher in each of the chosen community colleges would be in the sample. So that's cluster sampling. Then we have systematic sampling. This is where you randomly pick a starting point and then select every nth member. So like we start at person number 2. This could be like people walking through the mall, and you'll start with the second person, and then you will survey every third person after that. So person number 2, and then 1, 2, 3, person number 5, 1, 2, 3, person number 8, 1, 2, 3, person number 11. Those make up your sample, so every third. It doesn't have to be every third. You could define it a different way, like every 5th, every 10th, every 20th. It's up to you, but that's how it works. Then we have convenience sampling. A sample of convenience is one that's not done in a random way. So it's not a random method. So every member of this population does not have an equal chance of being chosen. So these are cement blocks. These, if you numbered each one of these and then did a random sample, you know, you might be asked or given, you know, the number for this block, and then maybe this block over here, and then maybe some block somewhere in the center but behind that block right there to be in your sample. And that would be very inconvenient to move the blocks around to get to the numbers and the blocks in the sample, because they would just definitely be too heavy. So this would be a case where it's okay to do a convenient sampling, and that would be just to maybe take 10 off the top. And the only reason that that would be okay is when your population doesn't differ systematically. So something like this with blocks where they're all basically the same, you can do that. You can't do that with people, because people are not systematically the same. So convenient sampling, for the most part, is not recommended. All right, so let's look at some sampling methods. A soccer coach selects 6 players from a group of boys aged 8 to 10, 7 players from a group of boys aged 11 to 12, and 3 from a group of boys aged 13 to 14 to form a recreational soccer team. So we want to figure out which kind of sampling this is. So look at what you're doing. You're taking a sample of 6 players from age 8 to 10, a sample of 7 from age 11 to 12, a sample of 3 from age 13 to 14. So you're taking samples from groups, so that would be stratified. Number 2, a pollster interviews all human resource personnel in 5 different high-tech companies. So you're interviewing all the personnel in 5 different companies. So these companies would be considered groups. And when you survey all the people in groups, that tells me that's probably clusters. So what they did was they separated the population into many high-tech companies, and then they randomly selected 5 of those high-tech companies, and then they surveyed everyone in the groups or in the companies that they selected. So that would be cluster. A high school education counselor interviews 50 female teachers and 50 male teachers. So this, again, you're separating the population into 2 groups, females and males, and taking a sample of each. So that would be another stratified example. A medical researcher interviews every 3rd cancer patient from a list of cancer patients. That sounds like systematic. And a high school counselor uses a computer to randomly generate to generate 50 random numbers and then pick students whose names correspond to the numbers. That would be simple random sample. And then last, a student interviews classmates in his algebra class to determine how many pairs of jeans a student in his school owns on average. This would be a sample of convenience. It's not a random sample because the population is students at his high school. He's only interviewing people in his algebra class. So not everyone in his high school has a chance of being chosen. So this is definitely a sample of convenience. All right, so we're going to stop the video here and